Okay, what I've got in front of me is a 3D shape. Right. It's a cuboid. Okay. Now, in this video, I want to talk about volume. And what is volume? Volume is the amount of space inside this 3D shape. But at the moment, it's only occupied by air. But what I'm going to do now, fill it up with Coke. So the Coke represents the volume inside that 3D shape, inside the cuboid. So you've got an understanding of what volume is. And later on, in a different video, I'm going to talk about surface area. Right? I don't want you to get confused with surface area and volume. And remember that Coke represents the volume inside that 3D shape, the amount of space within that 3D shape. Right, I'm going to drink this now. Right, even though I've drunk the Coke, but the volume hasn't changed. It's still got the same amount of space within that 3D shape, within that cuboid. Off camera, off the screen, I've got lots of 3D shapes which I'm going to bring into view in a moment. And what I'm going to do is split them up into two different categories. Some shapes will go here, some shapes will go over here on this side. And I want you to think why those shapes fall into those different categories. What is it that some shapes have in common to fall into one category, and what is it that the shapes have in common to fall in another category? Right, so here we go. I'll start off with this one. If you can see that. There, I'm going to put that one here. Let's get another one. Okay, see that? I'll put that one here. They've got something in common. I'll get another one. This one also I'll put here. Let's try to do something different here. Like this one here. You can see that will go into a separate category, not related to these. Try another one. This one here. Put it over here. Let's try this one. Belongs to this category. Now that might come as a surprise to you, thinking, well, these have got straight edges, this one's got circular, but they've all got something in common. Right, this one here, where do you think that might fall? Right, this one will go with these lot. This one, where do you think that one will go? Okay, I'll put that one with this. And in fact, there's a few like that one as well. See that one there? Okay, so what is it that these lot have got something, all of these have got something in common? And the ones I want to focus on in this video, these lot, right? So I'm not worried about these. That's for a separate video. All of these have got something in common. So if you look at this one, for example, what do you see here at the front? It's a shape, pentagon shape. Now, if I was able to cut slice right down here or here or here, anywhere along here, slice straight down like this, I will still get this pentagonal face, front face, no matter where I cut it. Imagine this was a cake. So if I was to slice it along here, I will still see a pentagonal face. Right. Right, look at this one. Right. You can see that there? You can see a circle. Now imagine that was a cake. If I was to slice anywhere along here, right, anywhere along here, I'll still see a circular face, front face, in the same size, exactly the same size. Even this one here, it's not a Toblerone, it's like a Toblerone, but let's say you've got the front face here, which is a triangle. If I was to slice anywhere along here, I'll still see a triangular face and the same size triangular face. And the same with these, this one here, these ones. Now, this back. In fact, all of these shapes are uniform, okay? You can see it along here, it's the same all the way, it's the same all the way through, right? That pentagon would be same all the way through, right? It's a pentagon all the way through. This one here, see that triangle there? Right. That triangle would be same all the way through. See the cylinder here? That circle, it's the same all the way through. Right. These shapes that I've got here are not prisms. Now you might want to say, right, these are all pointing up. That's what they've all got in common. True. This one's not pointing up. And neither is this apple. It's not pointing up. But they're not prisms. Right. Just imagine that this is a sphere. Just treat this like a sphere. A human being, right? You, me, right? Animals, objects, lots of different objects are not prisms. I'll explain why. Right. Take this apple for example. Right. Just imagine that's a sphere. Not quite a sphere, but just imagine it is. Now, if I was to take a slice, right, you can see a circle here. Yeah. Now, if I was to cut it further down here, if I was to slice it further down this way, you can see that front face area is a lot bigger now. It's a lot bigger. And if I was to slice it a little bit higher up, a little bit further up, I'd get a slightly bigger circle. Alright? But if I slice only a small section, a very tiny section, I don't know if I can do that. Let me try. See that? Tiny circle. So this front face area, what we call the cross-sectional area is tiny, but as you slice it further down, it gets bigger and bigger. It's not a prism. The reason why this is not a prism is because the cross-sectional area is different as you go through the shape. Different size cross-sectional area, right? It's not a prism. Same for this. You can see a point here, but if I was to cut it, let's say if I was to slice all the way through here, I would see 1, 2, 3. I would see a triangle, a small triangle. And if I was to go further down, let's say here, if I was to slice it further down, I would see a bigger cross-sectional area. Triangle, a bigger triangle. Not a prism. Remember, shapes like these are prisms, because if I was to slice anywhere along here, no matter where I slice it, I will still see the same size circle, same size cross-sectional area. But some of you might argue regarding this being a prism. I'm saying it's a prism, it's a cylinder, but it's a prism. Some of you might say, well, what about if you slice it this way? You might see a small rectangle. Then if you slice it right down the middle, all the way through, you'd see a big cross-sectional area, a big rectangle. So obviously you get different sizes. And then you might say, well, there you go, you've got different size cross-sectional area. It's not a prism, you might say that. But it is still possible with this shape to get the same cross-sectional area by slicing through it in the appropriate direction. We can still think of it as a prism. Whereas a shape like this, no matter which way you slice it, either this way or that way, right? You're not gonna get the same cross-sectional area. There's no way you can slice this in different ways to get the same cross-sectional area. Right, to find the volume of a 3D shape, you need to decide if it's a prism or not. This one is a prism, and we've already explained in detail what are prisms and what's not a prism. This one is definitely a prism. So if you're still not sure, please rewind the video and find out why this is a prism. All right? To work at the volume of any type of prism, it's the cross-sectional area, the front face, multiplied by the length. In that case, it's 5. So the cross-sectional area is a basic triangle. So we need to work out the area of that triangle. It's just base, look, base times the vertical height divided by 2. That's how you work out the area of a triangle, any triangle. 4 times 3 is 12, 12 divided by 2 is 6 centimeters squared. So the front face area, the cross-sectional area is 6 centimeters squared. Cross-sectional area, 6 multiplied by the length of the prism, 6 times the 5, that gives you 30 centimeter cubed. It needs to be cubed because it's volume that we're trying to work out. In fact, any type of prism, like this one for example, like this is a loaf of bread. Just pretend this is a loaf of bread. It's a cross-sectional area multiplied by the length of the prism. So if the cross-sectional area happens to be 100 centimeters squared and the length happens to be 10 centimeters, cross-sectional area 100 times the length 10. In this case, in this example, it's 1000 centimeter cubed. Right? So remember, for any type of prism, well, first of all, you need to decide if the shape is a prism or not. If it is a prism, it's a cross-sectional area multiplied by the length. That will give you the volume of a prism.